So today we're going to demo a self-study app that lets you create and edit your own exam questions and notes and tag them with various tags that you get to also create and edit yourself. Now I encourage you to pause the video here and read the 6 reasons I give for why I created this app and why it's useful, but I'm going to just move forward with the demo for now. So in order to create your own questions and notes, you have to create an account. So we're going to go to login. And if you don't want to create a new password, you can sign in with Google, gives you that option. We're going to go ahead. Now questions are like notes, but with more functionality. So I'm going to demo questions here and skip demoing notes. So I'll go to exam questions and immediately you see the tags. There are 4 categories of tags: topics, facilities, shout out to physicists who cover multiple facilities, products and versions, and references. Let's say today we're interested in 3 topics: Wisen-Lutz, photodosimetry, and MPC. So you select them, hit apply filter, and now you have all the questions that you have on these topics. You can either check out their details, the details of every question, you can edit them or delete them, but today what we're interested in is taking an exam on these questions. So we hit the Take Exam button here. Okay, first question. Your QA program includes Suncheck Machine, Wisen-Lutz, IsoCenter Check, as well as Variance IsoCal. Select all true statements about detection of MV imager origin drift. So here we have a snapshot of the Wisen-Lutz results in Suncheck, and there's a set of parameters here, the 3D offsets that are highlighted. The first option is MV imager origin drift is flagged by 3D offset parameters in Suncheck Machine, Wisen-Lutz, IsoCenter shown in image. The second option is MV imager origin drift is flagged by Variance IsoCal procedure, though of course you'd be relying on Variant for this check. So the correct answer here is the second one. Hit submit, and it tells you you're correct. The correct answer matches the answer you chose, and it gives you an explanation. So the 3D offsets in Suncheck Machine, Wisen-Lutz, IsoCenter Check tell you how to shift the mechanical or imaging isocenter, typically KV imaging origin, so that the radius of the sphere centered at this new shifted point and intersecting all beam axes is minimized. A drift in MV origin is abstracted by Wisen-Lutz QA, unless the physicist goes out of their way to check digital gradicular origin distance to ball or heterogeneity and MV images as they're obtained in imaging application. Okay, so next question, MPC is out of tolerance. What's the first thing you do? So first option is perform PVA calibration and repeat MPC. The second option is independently confirm outside of MPC that everything is okay before creating a new baseline. The correct answer here is second option, and you hit submit, and it tells you your answer matches the correct answer, correct, and it gives an explanation, and the explanation is as follows. There are 2 types of measurements in medical physics. The first is a consistency measurement, where you're comparing against the baseline and do not need to define anything in an absolute sense, meaning you do not need a calibration. The second type is an absolute measurement in which a calibration is either used or obtained. MPC uses a baseline and is therefore the former type. MPC uses dark field offset and pixel defect map, both from PVA calibration. So PVA calibration does touch MPC, but it doesn't touch it in terms of calibration, meaning rather than use the flood field gain from PVA calibration, it instead uses the baseline itself. In other words, the baseline stands in for the calibration, if you will. Next question. So here it's saying that you're performing dose normalization in the dosimetry section of PVA imager calibrations, and you see the following. What do you do? So this is at the end of the calibration where it's asking you whether you want to accept the correction or decline it. And actually, let's zoom in here a little bit. And you see that the current dose conversion factor, which is the conversion factor, before you accept the correction, is very different from the new dose conversion factor which is the one that'll apply after you accept the correction. So you would be changing the conversion factor by orders of magnitude. And the options are accept the calibration results because the numbers don't lie and you have to calibrate the EMV imager. Second option is call variant to schedule maintenance. Third option is decline and repeat, but remember to input different choices for reference, dose, CU input in Wizard. And the third option is the correct option here, and you hit submit. The explanation is that before you get to the screen, there's a screen that gives you an option to specify a normalization choice. And there are really two normalization choices, 100 MU per 1 CU or 100 MU per 100 CU. And the reason why you got this orders of magnitude differences is because you've specified a normalization choice that's different than your usual normalization choice. So if you repeat the test, decline and then repeat the test, but remember to tell the wizard which choice you've made in an earlier screen, then you will get reasonable numbers. And that's it. You hit finish exam, and it tells you your score, 3 out of 3. It gives you details about what happened with each question, and that's it.